Okay, so hello and welcome. Howdy. Gonna return to practicing some Java. Ooh, excuse me. Kind of a slow day today. I like to not waste time, spend time, just kind of seeing what's going on in the world, what other people's thoughts are on different things. I guess spend a lot of time on YouTube. But here we are. I want to try to solve some problems here, see how far we get. More Java. More Java. So we got Java big decimal. Let's go for it. Java's big decimal class can handle arbitrary precision signed decimal numbers. Let's test your knowledge of them. Given an array S of n real number strings, sort them in descending order, but wait, there's more. Each number must be printed in the exact same format as it was read from standard in, meaning that 0.1 is printed as 0.1 and 0.1 is printed as 0.1. If two numbers represent numerically equivalent values, 0.1 is equal to 0.1, then they must be listed in the same order as they were received as input. Complete the code in the unlocked section of the editor below. You must rearrange the array S's elements according to the instructions above. Excuse me. So you can, in order to preserve how they were read, the format, instead of like trying to convert back and forth, what you can do is you can actually just use like imagine like an array of these strings, and then you can sort. Oh, wait a second. Oh yeah, we want them sorted. Yeah. So, excuse me. So you can sort. You can sort the. I guess we could do it this way. You can have the array of strings, and there's an index, and then you have another array of these strings converted to decimal numbers, and obviously we want to use big decimal numbers because apparently these are very large numbers, potentially very small numbers. Excuse me. And what we're going to want to do is use a particular string. You can use maybe a hash map is better. You can use a hash map to hash the string to its actual decimal value, and then you can sort the strings using the hash map as part of the comparator. So I'll show what that looks like shortly, but yeah, that's kind of the approach I think we'll take. There is such a thing as like dumping the strings into like an array of tuples. Like that's probably how I would do it in C++, is to dump it into an array of tuples where the tuple has the string and its corresponding value as sort of two elements, so the string and the corresponding big decimal number is the second value, and then I would sort those tuples based off the second value, and that way, and then read off the strings in that from that order from those tuples. Alternative, like as I said, you can do what I'm suggesting here with the hash map. You can use tuples. You can also use, for Java, because you don't really have tuples, you can create a custom class that just has two data elements and the comparator for that class, such that you can then create an array of those objects and then sort those objects using the comparator, right, which would compare the big decimal portion. That's actually probably what I'm going to end up doing. I think we'll do it that way. So yeah. So excuse me. I don't know what's wrong with me, man. I'm not yawning so much lately. Complete the code in the unlocked section of the editor below. You must rearrange array S's elements according to the instructions above. First list consists of a single integer n, denoting the number of integer strings. Each line I of the n subsequent lines contains a real number denoting the value of S of I. That's 200, as most 300 digits. Output format locked stub code in the editor will print the contents of an array. Standard out, you're only responsible for reordering the array's elements. Okay, interesting. So I think it's a spam call. Write your code here. S of I. That's interesting. S is an array of strings. Yeah, I mean, this is fine. This is okay. So we can create an object. So let's say class, we'll just say, I don't know what to call this, like array entry. And we're going to say array entry is going to have two elements. It's going to be string S, and there's a big decimal. So I don't really know how that works. I don't know much about the big decimal class for Java. So we'll find out more about that. Excuse me. I don't know. Oh, rounding. Okay. 10, 0. Interesting. Big integer value. Can we use a string? Character array representation of a big decimal into a big decimal, accepting the same sequence of characters as the big decimal string constructor. Oh, neat. Okay. Let's try that. So you can use a string and just immediately big decimal small value. And so we're going to say for string S in, so we're going to say array of array entries. I don't know, just array. You know, we could probably or a record or something. And how many do we want? We want, this is going to be n plus 2, it looks like. That's interesting. Excuse me, why does this say n plus 2? What is that? That doesn't seem to make very much sense. I don't know, it should just be n. Yeah, okay. I don't know. Okay, oh, called string. So we can say array entry, new entry. And then we're going to say new entry dot s equals st. Entry dot value is equal to new decimal of the string st. Now we just need a comparator, I think, and then we can now. Oh no. How do I want to do this? We can use an array list. I think you're supposed to use capital letters. Yeah. While you're supposed to use camel case for your variable names, the class names you capitalize the first one. It's still camel case. Okay, list of array entries. Just call them entries. I'll do an array list of array entries. And then each time we're going to push add new entry. That's what we want to do. And then we're going to, create objects, both string and big decimal value of the string. Of the string. part. Members. Places objects to an array. Sort the array. I mean, really, just that's pretty much it. Excuse me. We do need to. I think set the comparator for this class. So something like this. So we could say S of I is then equal to entries of I dot S. And that should do it. Now we still need a comparator though. We can use anonymous class to write shortened code. Entries dot add new entry st new. Oh, good idea. Let's do that. Although I think the only issue with that is we would need. By the way, welcome. Yeah, I'm not sure if I said that. Welcome, Gustav Kumar. I don't know if I can. I can make this anonymous class have. But that's a good idea. I should do that more frequently. You'll notice I'm not super familiar with Java, so right, there's a lot of things, and I welcome it too. The like tips and tricks and advice and things like that. Thank you for that. I don't know. Can you do anonymous class that implements a comparator? Because I think if I want to use collection sort, I need a comparator interface. Like, can you use an anonymous class that implements an interface? I guess that's what I'm looking for. Somewhere here is sort. Let's see. I think that's what I'm looking for. Sort. Sorts the specified list into ascending order using the natural order. Yeah, so all elements must have been comparable. Right, that's what I'm thinking. And there's a compare to function that we need. So this is what we're going to implement. Right. Now, I don't actually know the best way to write this either as well. I make some assumptions about this. So we can do implements comparable. Right. Comparable, yeah, spelled that correctly. And so this is going to be int, and it's going to be compared to. Now the last time I did this, HackerRank actually had like a compared to TO. Actually had a code completion happened here, and I didn't need to write all of this. Okay, so we have compare to object O, and I guess we're going to say array entry of O. Call this array entry other, or X even. Other's probably fine. And we're going to say return. It's going to be so less than, so it's going to be val.compare to, so basically just forward this val.compare to other.val, right? Something like that. Let's see if that works. What does this do? Compilation error. Cannot implement compare to incomparable. Attempting to assign weaker access privileges was public, where T is a type variable. T extends object declared to an interface comparable. Array required, but list array entry was found. Oh, I forgot about that. It's a get. Does that work? This part? I don't know if that works correctly. But what is this part? Compare to object and array entry cannot implement compare to T incomparable. Oh. Huh. Weaker access privileges was public T, where T is a type variable. I don't really understand. I'm not sure if this. I actually don't know what's wrong. I'll find out though. Compare to cannot implement compare to T incomparable. Due to some weaker access privileges. Public where T is a type variable. Not sure I understand. Oh. Oh. Oh, comparator is not the same thing as comparable. But isn't... Why did I get... I'm doing this wrong. Why, I don't know what I was programming something recently and it told me to use an object here, not... I'm now very confused. Oops. We need to have the same access modifier. We cannot change the scope of access modifier from public to default. Oh, there's a default access modifier? I didn't even realize. In C++, there's only two. There's just private and public. I think there's protected too, private, public, protected, but everything's defaults to public, I think. And then if you don't specify it. Huh. Weaker access privileges was public where T is a type variable. Very confused. Don't know what's going on here. Also, what was I doing before where there was a compare to function that I saw that took an object, not a T. Well, anyway. I guess it's supposed to be some object T. But let's say let's do comparable. And let's do object. Well, can this be public? Is that what's wrong? I don't know. I'm so confused. I don't actually know. As I said, not sure what is wrong. Does this need to be a public class or private class? Oh. Interesting. So that works. That's weird. Why, for some reason that works. I don't know. I don't know, man. It compiles though. I mean, the solution's wrong, but for whatever reason. But that's super interesting. I don't know. Okay. So let's see, runtime error. Big decimal in it, null pointer exception. Now, why is that the case? Now, I don't actually know. Well, we used big decimal of st, right? Oh, maybe this doesn't have anything. That could be it. But there's no. I think it's this that's causing issues. That's my guess. Nope, it's not that. Where's that happening? It's runtime error. Let's see. Should have to use public. It runs, compiles, calculates because we are overriding the method. Oh. So because you're overriding the method, you need to. That's something I'll have to look into. Why that is the case. Oh, I guess because the method, I guess, is public, and so when you're overriding it needs to stay public. Yeah, that must be what I was describing about the weaker access modifiers. I think I should see what you're saying. Okay, where's my test? Oh, so we get all the way through it before we get a null pointer exception. So that's interesting. So where's this runtime error happening and why? So first, let's see if we can locate it, and then if we can locate it, then we can. I think it's here. Actually, this might be the runtime except problem. Just have unique messages. Doesn't really matter what the messages are as long as they're different from each other. We can recognize where they're being printed from. Oh, look at that. So we don't even get to. Oh, that's super interesting. We don't even get to this test 2. So actually, it is one of these. Huh. That's. What does that mean though? Hmm. 9 of these. Are no. Yeah, 9 integers. Get. Oh, that's why. Oh, I see it. Okay, duh. Okay. That's a very subtle thing. I was wondering that there was something wrong with that before. Like, there's not the array is not the right size, basically. I see the problem. That's very subtle. Yeah. Okay. I think we should be in good shape now. Wrong answer. Okay. Can get rid of this printout now. These debug messages. Yeah, it's definitely not an obvious thing. Okay. Message retracted. Oh, okay. All right. So now the question is, oh, so they want it sorted in descending order. Okay, so we just need to sort in the other direction. Now, is there a way to reverse the sort direction? There's probably 2 things we could do. We could sort use our own comparator, right? Or we can, to make it sort in the other direction, or we can use a reverse. So we can do 2 different ways. We can, which I think it was better to use a custom comparator. Reverse. Let's try that. See what we get. Oh, still wrong. Oh. Uh-oh. What happened? Oh no. Oh. Well, that's kind of arbitrary, isn't it? Because these are the same elements. Maybe it needs to be a stable sort. Maybe that's why. That's kind of arbitrary. Same thing with these two, right? That's somewhat arbitrary. Is this a stable sort? What are they suggesting here? Listed in the same order as they were received as input. Okay, so it's got to be a stable sort. So in that case, actually reversing won't do the trick. So we should write our own comparator then. So I think what you just suggested is a good idea. We can try to do an anonymous class that's a comparator, that implements the comparator, right? That's what we need. Or is it, implements the comparator interface. I mean, equal to this comparator? I don't know. Well, let's not do it anonymously for now. Let's do it this way. Or just custom compare. And this is going to be for the array entry. And now we're going to say two overrides, which are public. So this one makes sense to me. The compare to, or compare. The equals I'm not so sure about. I'm assuming this is a stable sort. I'm assuming it's a stable sort. The collection sort. So we can do compare array entry A to array entry B. Now I don't know if I'll be able to do this. I think so. If these are public, then it's doable, but otherwise it's a little bit confusing. So again, we return a.val, which you don't really need to do it that way. You can do a.val.compare to, and then b.val. Might not work if they're not, if these aren't publicly accessible, I suppose. And then the other item you have is, now I don't know if you need to override the second one. I don't know how this works, this equals. This .val.compare to o.val, we can use this. Overriding the method, yeah, sure. And the custom comparator. We have to check one more condition in comparator. I don't know. I don't know if that's correct. I'm not sure about that. Not sure about that. Can I see the question? Sure. Sure. It's here. Let me post it. You can open it in your own browser. Let me know if that posts. It's Java Big Decimal. So sorted in descending order, and then also use the original string format that was given to us. And if you see equivalent numbers, then you need to use a stable sort, meaning that the same order that they came in as input is how they're going to be in the output, which is basically what stable sort means. What is this? Equals object. Other object is equal to this comparator. This method must obey the general contract of object.equals object. This method can return true only if the specified object is also a comparator and it imposes the same ordering as the comparator. Comp1 equals comp2 implies that sign of comp1 equal to compare. O102 is equal to the sign of comp2 compare O102 for every object of reference O102. It's always safe not to override. Always safe not to override. However, overriding this method may in some cases improve performance. Okay, I don't want to override this, basically. We'll just, do it that way. Now, I don't really know. I don't really know how to set these things up so I don't use too much code. So we want to use custom compare for our sort. again, assuming that these will be public and that this is going to be a stable sort, which I don't know. And then that should work. Cannot find symbol custom compare. It's right here. Oh. Interesting. So, oh, you actually create that. You create it. Where is our? Yeah, that's another kind of interesting thing with. It's kind of an interesting thing with. Excuse me. It's an interesting thing with. I guess call them functors, maybe, or yeah, functors, objects where you can call the object and use a method that's part of that object. So yeah, it's kind of a neat thing because we're creating a class that has a function that we're going to call the function on that object of that class. It's a very kind of like almost convoluted, but it's not the class that you give the class name. You actually create an instance of that class and you give that, which is also true in the it's also true in the still wrong. It's also true in the C++ case. You do a similar thing. And actually we want the opposite. We actually want to reverse these two. So we're going to do b.val compared to a.val. And we're going to say, whoops, there we go. We're going to compare in the reverse direction by swapping A and B. Rather than less than. So that works. So it is stable. That's what I was hoping. I kind of assumed that would be the case. That this collection sort is. Usually it is the stock sorting algorithms. All right, let's see if it works. Let's see how we do. Great, thanks. Yeah, there we go. Got him. Ta-da! Yeah, that shouldn't have taken so much time. That took me a while because okay, so a few questions are like, can we shorten this, right? You were suggesting you can use an anonymous class, but the tricky thing about using an anonymous class is, can we do this anonymously, and two, can we do this anonymously, and two, what would that look like if you do that? I mean, certainly we can use anonymous classes for these array entries. That makes sense. But then the question is, when you write your comparator and you try to sort these, I think what you've got to do is, I guess first things first, you would actually put in your anonymous comparator class this function. That's the first thing. And then what does this function look like? I think this function would have a yeah, there is syntax to do that. I know I've seen that before in Java, to like basically construct an anonymous class and also change the like in your while you're creating the object, you can also modify the like the functions available to that object, I guess. Collection sort entries, new comparator array entry. I think you're typing the rest of it. But if we use an anonymous class also, right, for the array entry. So I mean, it could just be objects. It's fine. I think it's okay. We could just, but I think the tricky thing with the comparator is that it would be objects, so object A, object B, and then you would have to assume that that object has a value for the big decimal, which is the tricky part, I think. I think that's the part I'm kind of struggling with. Well, let's try it. Let's see what happens. Let's try something slightly different. So instead of entries, we're going to call these anonymous objects, just object, array, new array entry. Oops, actually let's do this. Let's not get rid of the code that we have here. This isn't really necessary to do this way, but I kind of would prefer to do things a little bit more abstractly if I can. So there'll just be an array of objects, right? And then array entry, it'll just be object, new object. And it's not, we don't actually need that anymore. We can do the entry, it's actually, hold on. Let's, like I said, let's keep the code that we had intact by commenting it out. And then we'll say entries.add new anonymous class, which I don't really know how that works in Java. Let me read the docs if you don't mind. I know I know it's posted in the chat how to do it, but I think it's probably better to read the docs directly about anonymous classes. Local classes are class declarations. Anonymous classes are expressions. It means you define the class in another expression. Following example, anonymous classes uses anonymous class in the initialization statements of local variables, but uses a local class for the initialization of the variable. Okay, interface, public void say hello, English greeting, implements hello world, greet someone. Okay. English greeting, new hello world. Okay, yeah, here we go. So this new hello world is an interface. Anonymous classes in the initialization statements for the local variables, French greeting and Spanish greeting. Okay. So even though there is okay, so you could do new comparator. Oh, I see. So it's an anonymous class that implements the comparator. I think I understand what you were suggesting. And then syntax. Mentioned anonymous class is an expression. The syntax of anonymous class expression is like the invocation of a constructor, except that there is class definition contained in a block of code. So it's an anonymous class that implements the interface. So it's not that arbitrary, I guess. Like, I guess you have to write the name of the interface. New operator, name of the interface to implement, or a class to extend. Okay, interesting. Anonymous class implementing the. Well, I guess you could do new object. I mean, it really doesn't have to be the comparator or the interface, right? You could always extend the object class, the base top of the hierarchy class. Entries, new comparator. Comparator, array entry, override public, compare A, B. Right, something like that, right. Name of interface to implement or a class to extend, anonymous class implementing the interface hello world, parentheses that contain the arguments to a constructor, just like a normal class instance creation expression. Note, when you implement an interface, there is no constructor, so you use an empty pair of parentheses, as in this example. A body, which is a class declaration body, more specifically in the body, method declarations are allowed, but statements are not. Huh. It's an expression, must be part of a statement. The anonymous class expression is part of the statement that instantiates the French greeting object. Okay, it's a semicolon after the closing brace. Right. Okay, interesting. Okay, so let's do a new object. And it's going to be, excuse me, string s equals st, and big decimal value is equal to, let's do it this way, Does this work? I don't know. Don't necessarily know if this is going to be correct. You can actually do probably this is better. Value equals big decimal of S. I don't know if that makes a lot of sense. Let's see what this does. Compilation error. ST is accessed from within an inner class. It needs to be declared final. Cannot find symbol. Or ST. Might be better. But what's the issue? Local variable ST is accessed from within an inner class. Well, I mean, what was your suggestion? New big decimal. Oh, you're right. Yeah, that's true. That's also the case. New array entry ST new big decimal. Right. Yeah, you could do that. Although that's not an anonymous class though, right? That would be. This is an anonymous class, but this needs a. I mean, you could do it this way. ST, right? And then you could say this has a constructor. I don't really know actually if this is the right way to do it. Could try this. Okay. Now what would that do? And this would be an override, I think. I think it's an override. I don't know. Or not. I don't think so, actually. Hold on. What does that do? Compilation error. Invalid method declaration return type required. Oh. Can't just override the constructor? Maybe it is an override. I don't know. No, return type required. Can you, in an anonymous class, can you override the default constructor? Capture variables, that's really what I want. Not declared as final or effectively final. So that's interesting. So I guess you have to declare them as final. I don't really know what that means though. Otherwise, I guess you would. I mean, there are a few things here. So we could try that route, could declare things final, and see what happens. Is that final? And then S would be TST. And then val is new big decimal of ST. How about that? What happens if we do that? Compilation error. No suitable method found for add. Anonymous object. It works! But no suitable method found? What do you mean? List int array entry is not applicable? Oh, that's why. These need to be objects now. Alright, how about that? How about this? Very interesting. Check that out. Okay. But that's super interesting. This actually compiles if you use an anonymous class in that way. Oh, seems correct. Don't know something related to object. Yeah. Let's see. Oh, comparator. Oh, we need. Cannot find symbol. Entries get IS. That's interesting. Wait. We had a compilation error here, but now. Now can we access S in this object? He should be able to, right? Public. Let's make these public. See what happens. No. Class object. Yeah, because it's not really an object. It's an anonymous object, so it doesn't know how to get this S. Well, all right. It's probably better not to try this. This is like very. we're trying to do things here that are a little bit strange, I guess. It's an anonymous object, but a list of objects. Yeah, probably not the best way to do this, I think. Probably shouldn't do it this way, but you can do something like this in C++ relatively easily. It's not that easy. You'd still have a tuple that you declare, so you really would have like an object up here that you would declare like an array entry. But this is very interesting, at least. To kind of try. So this new object, we have this string. But no, we won't be able to get the S in the value because the object class itself, we would need, if we could somehow save and store the declared type of this anonymous class, so we could somehow reference back to this anonymous class, then we would be able to forward that information here and use like a typecast, and then on this object. If we could typecast this object, then we can get the S. But we have to typecast it to the same type as this object, but we don't really know what type this is. We don't really have a way of storing that type either, that type information. So it's anonymous. Yeah. So that's really interesting. I don't know. Basically, you have to name. I mean, ultimately, it means you have to give a name to your anonymous class, which kind of defeats the purpose of having an anonymous class. Which it's interesting because in C++ you can have lambda functions. They're not really anonymous classes, but they're similar, and you can actually name them also. You can give a name to your lambda function, or it can be totally anonymous. So kind of neat. So yeah, let's we'll just create a class then, an inner class, and go from there. So we'll go back to what we were doing originally. I think that was okay. It was very interesting though to try this. Good thing we preserved our code also. But then the suggestion that you made down here, I like, to create a new array entry of st. Really, just st. I guess. Oh yeah, well you did st new big decimal. That's a good way of doing it too. St. Yeah, we can do it that way. And we just need to add a constructor though to the array entry, and just say array entry of sval. Yeah. Well, I don't know. So C++ has an interesting thing you can do. I don't know if you can do the same thing here for the constructor. If you do, you can do like this, ss, sort of like this. I don't know if it'll work exactly this way, even in C++, but it looks something like this for the constructor. Don't think they have the same syntax for Java. Yeah. Oh, you know what? I'm sorry. Let's see. What does this look like? Constructor, right? Yeah. So what do constructors look like for Java? Let me just see. Let's go to, where's this search somewhere, right? All classes. Let's say all classes. Whoa. Let's go object. Just. And let's just look at constructors. Is there maybe, constructor syntax in Java? Let's see. From the docs. Class contains constructors that are invoked to create objects from the class blueprint. Constructor declarations look like method declarations, except that they use the name of the class and have no return type. For example, bicycle has one constructor. Okay. Yeah, I think what you were describing before about using this dot XYZ is probably what I'm going to make use of here. So this, it looks like that syntax is not available in looks like it's not available in Java. So let's see. No, it out of the blue for Java, that syntax. String sum s equals sum val equals b. Yeah. So you can add a comparator. Not a comparator, constructor, and then construct in. But I don't think this is much better than just doing this and not bothering to add a constructor. I actually kind of prefer the latter. Well, the former rather. Actually, maybe the latter is better. We'll do it this way. That's okay. We can add a constructor. That's fine. Let's see if this still works, by the way. There we go, still works. All right, now what we want to see is our comparator we can make anonymous, I think. I think that'll work. Let's try that. I think that works nicely. Okay, so new comparator, and I think we want array entry, as you suggested, for this comparator. Oops. Let's try that. See what happens here. Does this compile? Hey, there we go. There we go. So we don't actually need this custom compare. We don't need to name it. I like that. That's okay. Sweet. Hey, we did it. Okay, I'll take it. That's not bad. That's not bad at all. Hey, man. That works. That works. Pretty clean overall. All right, let's go to the next one. Next problem. Not bad. It's probably enough for now as far as like anonymous classes and things. A prime number is a natural number, Java primality test, natural number greater than 1 whose only positive divisors are 1 and itself. For example, the first 6 prime numbers are 2, 3, 5, 7, 11, and 13. Given a large integer n, use the Java big integer class is probable prime method to determine and print whether it's prime or not prime. Oh, this is a really interesting thing. I think this implements an algorithm for prime. If it's probably prime, false. If it's definitely composite. So true, it's probably prime. Certainty is less than or equal to 0. True is returned. Certainty, a measure of this uncertainty that the caller is waiting to tolerate. It's willing to tolerate the call returns true. The probability that this big integer is prime exceeds this amount. The execution time of this method is proportional to the value of this parameter. This big integer is probably prime, false, but it's definitely composite. That's really interesting. So I guess I was gonna say it's easy. Yeah. So this primality check I think is based off of a great. I too able to get my concepts clear. Yeah. You and I both, right? We get an opportunity to kind of ponder it. You know, kind of test a couple things out. See, does this work like this? Does it work like that? Can you do it this way? Can you do it that way? I know what I think this is referring to. It's not a Bloom filter, but it's I'm sorry, it's not a Bloom filter. Not a Bloom filter. Although that's also a probabilistic kind of a check. What this is referring to is kind of unrelated, but tenuously related because they're both probabilistic algorithms, but probabilistic in the sense of like it's a Boolean, but in some cases it's absolute, but in some cases it's not actually necessarily known one way or the other. So I guess partially true, or is sort of the return output. It's sort of you get a maybe or you get sometimes it's a definite answer and sometimes it's a maybe. And that's probably the only reason why these are related to each other. But what it is probable prime. There is an algorithm, a primality test algorithm, which I don't remember the name of. But if you look it up, you can find it. There's Miller-Robin. No. Where is it? Probabilistic tests, yeah. So there's the primality test, apparently. The Miller-Robin, maybe it is Miller-Robin, yeah. More sophisticated, all composites. Yeah. Oh, my neck. Oof. Yeah, okay, so Miller-Robin's the one. But this is I think is what we're about to use. I think we're about to use a built-in implementation in Java of one of these tests. Interesting. Yeah, very interesting. Anyway, okay, getting offhand a little bit here, getting off topic, but that's it looks like a built-in implementation of one of these primality tests, probabilistic primality tests. Can I go with you on LinkedIn? I'm in college and would be very happy to learn from you. Yeah, absolutely. Yeah, sure. I'm on LinkedIn. It's my name, just H. William Plens. Just let me know. Oh yeah, I'll probably recognize your name. I think another person had asked a similar thing, and I said that was fine. Although I think he sent me the LinkedIn, but I didn't respond for a while. And I don't know. I hope that he stayed subscribed so I could apologize to him, because I just at the time I was really busy, so I hadn't looked at my LinkedIn for a while. But sure, I've sent the request. Thank you. And I'm assuming your name is this name, so when I see it, I'll recognize it and I'll add you, accept you. I actually forgot the other fellow's name, so again, I would, if he sees this, he can consider it an apology. I don't know if he would though. He's probably super busy. I don't necessarily know if he would necessarily the same name. All right, fantastic. So Gustav, and forgive me if I don't add it for a while for whatever reason. Don't take that as don't take that the wrong way. It's just I tend to be busy. Sometimes I forget. Sometimes I'm not always on LinkedIn. But I appreciate that. Thank you. Yeah, there was another fellow. I feel bad now because he had kind of a similar idea, and I don't know what happened. Like I said, so I recently, I should give you some context. So I recently had a job, and I recently quit. So I'm currently newly unemployed, but I worked, and I guess you could say at a financial services firm for roughly 4 years. Not quite. About 6 weeks would have been 4 years, but very close. So yeah. But I have, like I said, I recently quit. So I'm newly unemployed, and I'm interviewing with some places, but I'm also I'm interviewing with some places, but I'm also also studying. I guess yeah, that's really it. I'm just basically studying and interviewing, and kind of just taking things a day at a time. Okay, back to what we're doing. So this is really interesting. I didn't know that the big integer class has a probable prime function. That's pretty neat. I like that. I'm curious as to what algorithm is underneath, but well, it doesn't really say on the. There's probably you could find the documentation to find out which algorithm is being employed. Okay, single line containing integer m, the number to be checked, 100 digits, prime number, prime otherwise, not prime. Okay. Interesting. Only positive divisors of 13 are 1 and 13 and prime. Okay, so I mean, if we look at the big integer class, more likely than not, it has something just like the big decimal, where actually I want to do it this way. I don't know if we need to keep these tabs open. Realistically, we could probably close these. At the top, we should have a constructor. Where is that? Where is our constructor? Oh, there we go. Okay. Yeah, it should have a string. There we go. Yeah, I just wanted to confirm that before I wrote it. So we can do big integer. We'll just call it bi. Call it bi, new big integer of n. And then we're going to say if. So what do they say? You wanted to print prime or not prime? Oh. Yeah, it's just one line, one number. Okay. So if bi.is probable prime, is that what they said? Right? Yeah, is probable prime with a certainty factor. What certainty should we use? I didn't say. I don't know what certainty amount we should use. Is that a double? It's an integer. What does it say? 1 minus a half certainty. Maybe we use a certainty of 1, I guess. I don't know. I don't actually know what we should use. I don't. Is it possible for us to? I guess it doesn't matter. Sort of. Yeah. Okay. Kind of. I mean, it does matter, but it almost doesn't, because if it is prime, they're saying that it'll always come up that it's prime, right? Excuse me. What does it say? If it's probably prime, it'll be. It's definitely composite. It'll give you false. Okay. I don't know. Probabilistic methods is confusing, but trying to figure out whether or not the probability, the certainty factor that we select matters. So true if it's probably prime, we'll say prime. And definitely not prime, we say not prime. So if it's not if it's not definitely not prime, then it must be prime. Interesting. I don't know about this one. Yes, sir. That's the best part of these fields. We can learn anytime at any age. Yeah. Oh yeah. All right. Let's see what happens. I don't know. I'm just gonna go for it. I don't know. Oh, okay. All right. Okay. Why not? Fine. Sure. Probability, the certainty factor of 1. Fine. All right, we'll keep going. I don't know. There's not really a lot to learn with this. This is basically just an Java has its own implementation of a probabilistic primality check, and that's it. I mean, that's pretty much all we're doing here is we're just running that routine. One of the things about that though is you can, but there is some benefit here. Like if it's definitely composite, that'll show. So. Excuse me. If it's not definitely composite, we're assuming that it's prime. That's pretty much what we're doing in our routine here, which is like the logic of that is kind of confusing because we don't know with certainty that it's a prime, but it's not definitely composite, which doesn't mean it's definitely not composite. It just means it's not definitely composite. Yeah, that's confusing. I don't know. I guess. So that's kind of what I'm trying to determine is whether or not the certainty factor actually matters, and I don't know. Well, I don't know. I guess the way that they formulated the question, it doesn't matter, because it's pretty much anything where it's not absolutely certain. We're calling it prime, even if it is or isn't prime. So I suppose the certainty factor really shouldn't matter that much. So anyway, so I don't know. If we cranked it up to 10, let's see if anything changes. What would that mean if we cranked it up to 10? 1 minus if the probability that it's prime exceeds this amount. That's true. Okay. Let's see what happens. Okay, I don't know. Well, who knows? I don't know. I want to like break this. Put in like 10,000, see if we start breaking things. Nope. Oh, what are these test cases, man? I don't know. I don't know how they did that, where it'll work for all the test cases, almost regardless of what certainty factor you give. Who knows? 100% probability. Yeah, I guess so. I don't know how this works, how they did that, but that's pretty interesting. But anyway, that's a very I mean these probabilistic primality tests are pretty interesting to begin with. They're a little bit beyond me in terms of the maths. Like it's not like I couldn't figure it out probably, but I would need to sit and think about it for a while and kind of work through it. Probably find a video online of somebody who explains it. I would say that's a really good resource, by the way, using the internet to find like if other people have videos of explaining things. That's usually very good. I'm not going to go into those tests, how they work, not now. I tried once in the past and I was like, I don't really care that much. Wasn't that interested. Not that I don't care, but it's like, it was not as meaningful to me at the time. It wasn't like a super important thing for me to know. And there's like, I have like other priorities that are more urgent. So that's probably, I mean, that's a more sophisticated way of saying I didn't care. But yeah, saying that there were other priorities that kind of superseded that, doing that, I think it's a reasonable thing to say. It's a typical thing. Method in a subclass overrides a method in a superclass. It is possible to call the overridden method using super keyword. If you write super.funct to call the function, excuse me, forgive me, I'm going to be doing a lot of yawning. Lately I've been doing that. Call the function func. It will call the method that was defined in the superclass. You are given a partially completed code in the editor. Modify the code so that the code prints the following text. Hello, I am a motorcycle. I'm a cycle with an engine. My ancestor is a cycle. Oh, software development's great. Yeah, this is like a joke, you know. Oh, you love your car more than me. It's like, well, in this case, person love your motorcycle more than me. It's like, well, this guy talks to his motorcycle, and it talks back. Okay. Oh no, excuse me. The motorcycle talks to him. I'm sorry. Hello, I am a motorcycle. I am a cycle with an engine. My ancestor is a cycle who is a vehicle with pedals. Excuse me. Cycle with an engine. My ancestor is a cycle who is a vehicle with pedals. Okay. So there's the cycle. There's the... Okay, I think I get it. So basically, the motorcycle is a subclass of a cycle, or just like a bicycle. Really not necessarily a bicycle, but something that has pedals. Okay. Interesting. What do we modify the code so that the code prints the file? We're actually gonna. That's how we're gonna participate here. Okay. Call this function. We'll call the method that was defined in the superclass. All right. Interesting. So how does this work? It's hello motorcycle. I am define me. Return a cycle with an engine. Excuse me. I am a cycle with an engine. And then we're going to temp define me, fix this line. Okay. And then my ancestor is a cycle who is temp. So temp, we want that to be a vehicle with pedals. But we're saying we can do super, right? So you could do this, which technically would work, I think, right? Not really what we want, though. We want to do... Oh, I think I understand what they're getting at here. Technically that would work, but that's not what they want. They want... This is a constructor, this part. Can I not scroll down? Am I missing something? Oh, there we go. Okay, that's what I was missing, yeah. So this is the motorcycle constructor. You want to call... You could do super define me. And that would be what we're after. I think that's what they're suggesting, to do that. Super.define me. Right, gotcha, thank you. Yeah, sometimes it can be challenging to understand what they're asking. Okay, well that's a pretty easy question. But now what's interesting though is it accesses the ancestor class's function. This isn't actually a constructor that it's calling. It's actually calling the function, not the constructor, which is kind of interesting. It's a method that was defined in the superclass. Okay. Excuse me. So when a method in a subclass overrides a method, it is still possible to call the override method. So this is like really kind of subtle, kind of interesting. I'm glad they went over it. So the idea is that you're actually overriding a method, but you want to call the method that you're overriding. You still have access to it using super. That is a very subtle thing, very nuanced thing. And that also applies to constructors. So you can call the previous class's constructor, but it applies for any method, not just constructors, which actually most of the time I've only ever really seen that or used that using constructors. So interesting. Okay, sweet. Let's keep going. Java instance of operator is used to test if the object or instance is an instance of the specified type. In this problem, we have given you 3 classes in the editor: student class, rockstar class, hacker class. I'm wondering now if there is a way to actually, if we have an instance of like runtime type, so in C++ you have this RTTI, it's called runtime type inference, runtime type, excuse me, is it RTTI? Runtime type information, RTTI, yeah, that's what it's called, RTTI. Let me see, can I get, there we go, type support, RTTI, right. So RTTI stands for runtime type information, and you can know the type of something at runtime and use that in your program. Whereas I guess what I'm wondering is I wonder if Java has RTTI support. I think it does, but I don't know if it does. I haven't learned, I guess, if it does, how to use that. But this instance of is a type of is a form of RTTI support. I want to say that's kind of what I'm getting at. I want to say you need to have some type of RTTI support in order to use an instance of operator. I think that's the case. Yeah. This problem, we have given you 3 classes in the editors: student class, rockstar class, hacker class. In the main method, we populated an array list with several instances of these classes. Count method calculates how many instances of each type is present in the array list. The code prints 3 integers: the number of instance of student class, the number of instance of rockstar class, the number of instance of hacker class. But some lines of the code are missing. You have to fix it by modifying only 3 lines. Don't add, delete, or modify any extra line. To restore the original code in the editor, click on the top left icon in the editor and create a new buffer. So the idea, I think, is to use instance of to figure out which class this particular I guess an object is, and then we're going to count each of these, increment each of the integers associated with the number of each. Okay, fair enough. It's an easy. Okay, I think so. Yeah, so 3 students and 1 rockstar, 1 hacker. Okay. Also, that's kind of cheesy. Students, rockstars, and hackers. Okay, fair enough. All right, don't flatter me too much now. Don't flatter me too much. Get to be a. Can we throw ninja in there? Could be a ninja rockstar hacker student. There you go. You can. All right. Anyway, okay. So count my list. What does it do? Array. So only will modify 3 lines. Okay. ABC element, my list, object, so instance, so if, so really it's just if element, if instance of element. Now I don't know, we could say dot equals or is equal to student, something like this. And the question is Java instance of. Let's either find the docs. WebLogic, whoa. Not necessarily, but maybe. JavaScript. Not instances of, but instance of. Shouldn't there be something for Oracle? From Oracle? Oracle, as I understand, actually built Java, so that's why I'm looking for their their explanation. It's almost like you'd want to go from the person who built it to ask about how to do certain things. Ideally. It's midnight in India. I'm gonna go to sleep, sir. Bye, sir, and good night. Have a great time. All right. I'm glad you enjoyed yourself. Take care, Gustav. Talk to you soon. Yeah, have a good night. Take care. I'm grateful you came by and said hello. Yeah, get some sleep, man. Don't stay up too late. That's no good. You gotta get sleep. Sleep is super important. Extremely important. Gotta get plenty of sleep, especially for a student. Particularly for a student. Very important. Empty operator and operands can be added later. Add sub-expression on this. Instance of, what is this? This is from Oracle. Yeah. Instance of operator. Extends operator, influence binary operation. Excuse me, the object parameter, which can be an expression as an instance of a class type. An object or expression returning an object, a class, or an expression returning a class. Oh, really? A Boolean. So that's, okay. So it's actually student, element student. I think that's actually what the operator does, or what it looks like. So student, so the first one A, it's actually, well, yeah, actually it should be the right order. Rockstar and hacker. Okay. All right, what does this look like? Compilation error. Instance of illegal start of expression. What? Class. This is kind of weird, this page. It says Oracle, but it looks odd. Um, hmm. Um, hmm. I don't know. This is a little bit strange. Instance of operator. Can I see examples where it's used? Oh, okay, I get it. Got it. It's kind of got that sense that I was not using this correctly. Okay, there we go. Good night, sir. Yeah, good night. Good night. Talk to you soon. Talk to you soon. Enjoy your rest. Alright, that's I think what we're supposed to do. They didn't show us the instance of operator, what it looks like in use. So I didn't really know what I was looking at there. Well, that's interesting. Okay. Fair enough. Yeah, if you could name a class or store the name of a class. Well, I guess you sort of can. Just, I don't know. I'm just thinking giving an anonymous class a name just seems very... it's like what defeats the purpose of making it anonymous. So, let's see. Did we get it? Did we do it right? Make any mistakes? Okay, I think we're okay. Alright, nice. Okay, next challenge. Java Iterator. Java Iterator class can help you to iterate through every element in a collection. Here's a simple example. How are we doing? Yeah, go to 30 questions. Java util example, void main, my list, hello, Java 4, iterator, while it has next, okay. Fair enough. In this problem, you need to complete a method func. The method takes an array list as input. In that array list, there is one or more integer numbers. Then there is a special string ###. After that, there are one or more other strings. A sample array list may look like this. You need to complete a method func. The method takes an array list as input. In that array list, there is one or more integers, and there's a special string ###. After that, there are one or more other strings. Okay, interesting. But so these are objects, I guess, that could be an array. It could be an integer, or it could be, there could be one or more. Excuse me. Okay, I see. So there's a sequence of integers, then there's a string, and then there are other strings. Okay. Modify the func method by editing at most 2 lines so that the code only prints the elements after this special string. A sample above, the output would be this. Centerin does not contain the string is added in the main method. Restore the original code in the editor, click the top left to create a new buffer. Okay, that's fine. So object element complete this line if use instance of. Okay. All right, iterator is an instance of. All right, sure, why not? So what does it say? Main scan in, we have an array list, which doesn't specify the object. We scan things, we have an next int, and n and m, I guess number of integers, probably number of strings. Add to the list integers, and then add. Now this is kind of interesting. It looks like this is an array list of objects that can be both integers and it could be strings. It's kind of interesting. I guess it's like it could be a union object, some object that has both of those. I don't know. I wasn't really expecting that. I guess just an array list of objects maybe. And then iterator func my list, it equals func my list. It has next, element equals it dot next, string element print. Wow, very interesting. Very interesting. So yeah, I mean, I guess our iterator is going to be presented at. So start at the beginning. If you have something, then we're going to set this object to be has the next really. It dot next, and then if it really should be this element is an instance of string, then it looks like we break, right? The idea is to, yeah, because we got that pound element, that's the string, and then now our iterator is actually going to be past that now. Once we've found that. So okay, I see what they're suggesting. All right, let's go for it. Hey, very good. Okay, got it. How are we doing on time? It's been an hour and a half. I mean, we can keep going. We can keep going. Yeah, we got another 34 questions. Okay, that's fine. Java hash set. In computer science, a set is an abstract data type that can store certain values at any particular order and no repeated values. Wikipedia 123 is an example of a set, but 122 is not a set. Today you will learn how to use sets in Java by solving this problem. You are given n pairs of strings, 2 pairs A, B, and C, D are identical if A equals C and B equals D. That also implies AB is not the same as BA. After taking each pair as input, you need to print the number of unique pairs that you currently have. Complete the code in the editor to solve this problem. So one more time. So given pairs of strings, 2 pairs are identical. Also implies AB is not the same as BA. After taking each pair as input, print the number of unique pairs you currently have. Complete the code in the editor to solve this problem. So this is kind of interesting. I was actually just working on something like this not too long ago where I needed a hash map rather than and I used a tree map instead of a hash map. So input format. In the first line, there will be an integer t denoting the number of pairs. Each of the next t lines will contain 2 strings separated by space. In the first line, there will be an integer t denoting the number of pairs. In the first line, there will be an integer t denoting the number of pairs. In the first line, there will be an integer t denoting the number of pairs. Okay. Each of the next t lines will contain 2 strings separated by a single space. Okay, so those are the pairs. Okay, fair enough. Length of each string is at most 5 and will consist of lowercase letters only. Okay. T lines, ith print output. Unique pairs. Wait, what? Print T lines. Why? In the ith line, print the number of unique pairs you have after taking. Oh, okay. That's interesting. You know, I mean, that seems kind of unnecessary. Like you could just print the total at the end, but sure. Taking the first input, you have only 1 pair, John, Tom. After taking the second input, you have 2 pairs, John, Tom, and John, Mary. Third input, you still have 2 unique pairs, and so on. Okay, I get it. So we're gonna use a hash set to store our pairs. That's kind of what they're going with here, or going for here. So sure. The question though is pair left, pair right. These are arrays of strings, sure. But the issue is, excuse me. Okay, how might you do this? And this has to do with the hash set object itself. So job state reasons and linked hash set. So I think I want to use a linked hash. What is this? What is this? Job state reasons. Job state reasons is a printing attribute class, a set of enumeration values that provides additional information about the job's current state, i.e. information that augments the value of the job's job state attribute. Instances of job state reason do not appear in a print jobs attribute set directly, rather a job state reasons attribute appears in the print jobs attribute set. The job state reasons attribute contains 0, 1 or more than 1 job state reason objects which pertain to the print job status. The printer adds a job state reason object to the print jobs job state reasons attribute when the corresponding condition becomes true of the print job, and the printer removes the job state reason object again when the corresponding condition becomes false, regardless of whether the print job's overall job state also changed. So I think there is this idea of like solid principles about programming and kind of making things abstract and all that. This is like printer related code that's been found its way into like the core Java code, code or code base, or whatever you want to call it. Like is this literally like just for printers? Is that what I'm looking at here? That's a very peculiar thing to have in the Java, I guess, yeah, standard library. Probably not what we're looking for as far as using a hash set. Printer jobs? What does printing have to do with hash sets? That is funny. But extends. Excuse me. Extends hash sets. That's very peculiar. I would not use that for my hash sets, but okay, it's fine. All right. Anyway, so the elements themselves implement serializable, clonable, iterable, collection set. Oh yeah, serializable. This is the thing I think that we need. Yeah. Now, is it the set that's serializable, or is iterable collection set? I actually don't know what these interfaces are, what we're dealing with. So yeah, we should probably just read this then. Hash table and linked list implementation of the set interface, which with predictable iteration order. This implementation differs from hash set in that linked hash set. Oh, okay, it's different from hash set. Maintains a doubly linked list running through all of its entries. This linked list defines the iteration ordering, which is the order in which elements were inserted into the set insertion order. Note that insertion order is not affected if an element is reinserted into the set. An element E is reinserted into a set. S.add E is invoked when S.contains E would return true immediately or immediately prior to the invocation. So actually we don't need linked hash set either, we just need hash set. Implementation spares its clients from the unspecified, generally chaotic ordering provided by hash set without incurring the increased costs associated with tree set. Can be used to produce a copy of a set that has the same order as the original, regardless of the original sets of implementation. Oh, that's interesting. This technique is particularly useful if a module takes a set on input, copies it, and later returns results whose order is determined by that of the copy. Clients generally appreciate having things returned in the same order they were presented. This class provides all of the optional set operations and permits null elements like hash set. It provides constant time performance for the basic operations add, contains, and remove. Assuming the hash function disperses elements properly among the buckets, performance is likely to be just slightly below that of hash set due to the added expense of maintaining the linked list, with one exception: iteration over a linked hash set requires time proportional to the size of the set, regardless of its capacity. Iteration over a hash set is likely to be more expensive, requires time proportional to its capacity. Excuse me. Linked hash set has two parameters that affect its performance: initial capacity and load factor. They are defined precisely as for hash set. Note, however, that the penalty for choosing an excessively high value for initial capacity is less severe for this class than hash set, as iteration times for this class aren't affected by capacity. So I don't really understand how these are implemented. I don't see how you can implement a linked list for your hash set, or use a linked list as your underlying structure. Linked list defines the iteration ordering. It is the order in which elements were inserted into the set. Note that insertion order is not affected if an element is reinserted into the set. An element is reinserted at E. Spares unspecified generally chaotic ordering. Yeah, I don't get it. I don't know, how do you implement a set with a doubly linked list? Because you have a hash function. That's how hash sets work for the most part, is they have like an array and you have a hash function, and then you enter your element at that particular position. But for a doubly linked list, you would need to I mean, maybe it's like an array list type of thing, because I always thought that was kind of weird. Like, how is the Java array list implemented? Right? That's another question. It's kind of an unusual thing. It's supposed to be a list, so like a linked list, but it's also an array. Excuse me. Okay. Get, set, iterator, list, iterator operations running constant time. Class is roughly equivalent to vector, except that it's unsynchronized. Okay, interesting. So an array list really is like an array. It's not really as much of a list as it is an array. Now, a linked hash set is a linked list, but excuse me. Ooh, excuse me. What are the? It's not synchronized. What are the runtimes for the add, clear, contains, remove from hash set? What are the runtimes for these things? It really doesn't. I think so it's got a whole lot of methods that it inherits. It doesn't really override any other methods. I think it's just. I think the idea is it's actually a hash. It is a hash set. How you would normally construct a hash set. Except, which I don't actually know how the hash sets work in the first place, right? Like how they're implemented. Like I said, I usually would use an array, and then you'd use an array, and then if you needed more capacity, you would increase the size of that array, and you'd have a hash function that sort of gives you sort of a key for each element. Sort of has a hash value, and that's a sort of entry point in the array. It's position in the array. And obviously you could have multiple things at the same position in the array, and each of those you would just add, just make a linked list for those. Maybe that's what this is. Maybe this is actually a. I think this might just have a linked list on top of your hash set. So okay, I think I understand. Yeah. So there is a doubly linked list in addition to the hash set that runs through all of the entries. Okay, I understand. So when you remove an element, you don't necessarily remove it from the doubly linked list, actually. Okay, I think I understand. So you can, and actually in amortized constant time, you can maintain that list, I think. Because you could say, okay, when you remove an element, if it's not from the front of the list, then you would just mark that element as removed from the hash. In fact, you can actually, the linked list itself, when you run through the linked list, I guess it's really the only time you would, you can just check to see if that element that's associated with that part of the linked list is still in the array and in the hash set. And if it's not, then you would remove it from the linked list, and you wouldn't return it in your iteration. But if it is, then you can return it in the iteration and you keep it. That's pretty much it, I think, actually, really. That might not be the best way to do it, because you don't want to pay that penalty too often. Like not that you don't want to pay too often, but you don't want to pay that penalty for, I guess, removing all those elements from the linked list in one awkward spot, I suppose. Like you'd want that to happen every so often, so that way it's relatively speaking reflects what's in the set. Okay, I think I understand. Yeah, that's a very interesting like data structure. But so I guess when you like increase the size of your hash set, you probably would also run through, or decrease the size of your hash set, whichever one it is. When you increase or when you modify the capacity, you probably would also just update this doubly linked list in addition, so that amortized cost is sort of linked together. Yeah, you can do it that way. That's pretty interesting. So this allows you to. This actually just maintains the order of the hash set. It's actually not really different at all from the hash set, or not very much different. Neat. Okay. So what do we need to have a hash set? We have serializable, clonable, iterable collection set, and then some known classes. Now, I don't think this is abstract. Class implements the set interface backed by a hash table, actually a hash map instance. It makes no guarantees as to the iteration order of the set. In particular, it does not guarantee that the order will remain constant over time. This class permits the null element. Offers constant time performance for the basic operations. So we actually want hash map then, is what we want to look at. That's more what we're looking for. What time do we have here? Hour and 45 minutes. Okay. Not too bad. I don't know. I'm thinking about taking a break after like a while, I suppose, sometime. Okay. Serializable, clonable map KV. We don't need to look at these. Hash map. Hash table based implementation of the map interface. This implementation provides all of the optimal map operations and permits null values in the null key. Hash map class is roughly equivalent to hash table, except that it is unsynchronized and permits nulls. This class makes no guarantees as to the order of the map. In particular, it does not guarantee that the order will remain constant over time. Right. This implementation provides constant time performance for the basic operations, get and put, assuming the hash function disperses the elements properly among the buckets. Iteration over collection views requires time proportional to the capacity of the hash map instance, the number of buckets plus the size, the number of key value mappings. Thus, it's very important not to set the initial capacity too high or the load factor too low if iteration performance is important. An instance of hash map has two parameters that affect its performance: initial capacity and load factor. The capacity is the number of buckets in the hash map. The initial capacity is simply the capacity at the time the hash table is created. The load factor is a measure of how full the hash table is allowed to get before its capacity is automatically increased. When the number of entries in the hash table exceeds the product of the load factor and the current capacity, the hash table is rehashed. That is, internal data structures are rebuilt so that the hash table has approximately twice the number of buckets. Yeah. So this is the this is where you get the amortized factor. It's still amortized constant, but it's not constant, right? Because when this happens, this is a linear cost. General rule: the default load factor offers a good trade-off between time and space costs. Higher values decrease the space overhead but increase the lookup costs reflected in most of the operations of the hash map class, including get and put. Expected number of entries in the map and its load factor should be taken into account when setting its initial capacity so as to minimize the number of rehash operations. If the initial capacity is greater than the maximum number of entries divided by the load factor, no rehash operations will ever occur. If many mappings are to be stored in a hash map instance, creating it with a sufficiently large capacity will allow the mappings to be stored more efficiently than letting it perform automatic rehashing as needed to grow the table. Yeah. It's very similar to the arrays or vectors in like C++, where you have to spend extra time increasing the size of the vector as you add more elements to it. It's like the same thing. It's basically as you add more elements, you have to increase the size of the hash map. It's basically what's being described. It's not synchronized if you access it concurrently. One of the threads modifies the map structurally. It must be synchronized externally. Structural modification is any operation that adds or deletes one or more mappings. Merely changing the value associated with the key that an instance already contains is not a structural modification. Typically accomplished by synchronizing on some object that naturally encapsulates the map. So if no such object exists, the map should be wrapped using synchronized map method. It's best done at creation time to prevent accidental unsynchronized access to the map. Fair enough. Iterators returned by all of this class's collection view methods or fail fast if the map is structurally modified any time after the iterator is created in any way except through the iterator's own remove method. The iterator will throw a concurrent modification exception. Thus, in the face of concurrent modification, the iterator fails quickly and cleanly rather than risking arbitrary non-deterministic behavior at an undetermined time in the future. Note that the fail-fast behavior of an iterator cannot be guaranteed, as it is, generally speaking, impossible to make any hard guarantees. The presence of unsynchronized concurrent modification. Fail-fast iterators throw concurrent modification exception on a best effort basis. Therefore, it would be wrong to write a program that depended on this exception for its correctness. The fail-fast behavior of iterators should be used only to detect bugs. Neat. Wow. Okay. Is a member of the Java. So like this is all stuff when I was younger. I think I remember reading this and just being totally confused and lost and just having no idea what they're talking about. Now I finally get it. I mean, like now I have enough experience, I guess, with stuff to understand it. I think it probably could have been explained to me when I was younger too. Like it didn't have to take so long for me to understand these things. But for some reason this was hard at the time when I was younger. What I'm interested in though is the objects that I can hash, right? So the implemented interfaces are serializable, clonable, map, and what objects can I give to the hash map? Can it be anything? Can it be any entry that I can hash? The hash map hashes objects, so I think I can hash any object that I'm thinking about it. I think I don't actually need to have a I actually don't think I need to have a hash algorithm for my objects, because I think it just hashes any object. So we can create an object for a hash map. Is it that simple? All right, let's try that. John, Tom. So we'll create an object, create a pair, call it string pair. Actually, wait a minute. What are we doing here? So, oh yeah, this is part of the main. All right, so we'll call it class. So string pair, right? And we'll just say string S1, S2. Both of these will make them empty initially. And then we're going to say string pair of string A, string B, and just say S1 equals A. Actually, we should do AB. I like that better. And we'll just do this dot A and this dot B. Okay. Let's see if that compiles. All right. Now we want a hash set of string pairs. We'll call it H. I don't think the objects need to have any kind of, so that's the thing, I don't think they need to implement anything. I think that because they're objects, they just automatically have a hash ability to them. And we'll say, so pair left, pair right. So we're going to say for int I equals 0, I is less than t, plus plus I. And we're going to say, string pair of, let's say sp equals new string pair of, we're going to say pair left of I, pair right of I, and we're going to say if h dot contains sp. If it does not contain sp, then we're going to h dot add sp, and we're going to say system dot out dot print line of h dot size. I think that's it. I think that's all they want us to do. Something like this. My output, expected output. 1, 2, 3, 4, 5. 1, 2, 2, 3, 3. All right. So that's very interesting. Maybe we just need an equals kind of a thing going on here. I don't know. Yeah, see, that's very interesting. And maybe it just doesn't work properly if we do it this way. So map KV. Type of keys maintained by the map. Type of map values. Bindings, concurrent map, concurrent navigable map. Logical context, message context navigable, sorted map. Implementing classes. Map attributes, auth provider. Oh, well. Sub interfaces. Interface. Oh, okay. Map entry key value pair. Okay, maybe that's what we need. Oh, I see. Interface map entry. A map entry key value pair. The map entry set method returns a collection view of the map whose elements are of this class. The only way to obtain a reference to a map entry is from the iterator of this collection view. These map entry objects are valid only for the duration of the iterator. Iteration, more formally the behavior of a map entry, is undefined if the backing map has been modified after the entry was returned by the iterator, except through the set value operation on the map entry. Map.entry set equals get key, got value, hash code. Oh, here we go. So yeah, so that's what we want. We want a map entry. So we want to extend the map entry interface and set the hash code. So we want our string pair to have a hash code, basically, is what we're looking for. Hash code of a map entry E is defined to be get key equals null or 0, get key dot hash code dot get value dot hash code. Okay, so get key dot hash code ORed with get value e dot get value dot hash code. Excuse me. So we just need a hash code for our string pair. I think that's all we need. Could try that. Yeah, it's K is what we're right. So, excuse me. Get key. Huh. I don't actually know. Does that work? Can we do that? Cannot override hash code. Oh, okay. Still wrong, but better, I guess. Okay, well, we get our string pair hash codes. Do we need equals maybe? What happens when we do this? I think this is the point of this exercise, to go through these different things. Oh. This doesn't override anything. Okay. No. It's not working. Yeah, this is, like I said, this is something I kind of touched on recently, where I used the tree map because I couldn't sort out how to use the to properly use the hash map. But why? What is? All right, let's look at contains. Right, if we look at hash map or hash set, let's look at how contains is written. Contains a specified element more formally returns true if and only if the set contains element E such that O is equal to null, E is null, O dot equals E. Okay. Yeah, I mean, we have to have an equals, right? So we wrote that. Okay. Contains interface collection, interface set, overrides abstract collection. Parameters element whose presence in this set is to be tested. True if the set contains the specified element. Okay. Well, you need to have an equals. What's the hash code for the string class? Okay. Yeah, so they have a hash code. Nice. All right. So yeah. Get two hash codes for A and B, and then you just take the hash code of a string pair is going to be an XOR of A and B. Okay. But why doesn't this work then? Create a string pair. If our hash set doesn't contain a string pair, we're going to add it. And then check the size. Let's do a debug. All right, let's do it this way. For string pair SP, X, and H, excuse me. We're going to say use a formatted string to be x.a, x.b on a new line, s space s. Okay. What does this look like? Whoa. Input John Tom. Why? Oh, I see. Oh, that's my mistake. Okay. John Tom, Mary, John Tom. Now this should not be so. For some reason, they're missing each other. These should be registering as the same value in the hash set. John Mary, John Tom, Mariana, John Mary, John Tom, Mariana, John Mary. Okay, so a couple of things to note here. I can actually just create a hash set of strings and then just combine the left and the right with a space in between to make a single string. I could do that. And then this would work very easily. This would work correctly. I guess that's why this isn't easy. However, I do want to know how one is supposed to hash like tuples of things, so like pairs of things, like how one could conceivably do this, take this approach. In other words, make a string pair class and use that as the hash key rather than just as a string that's the concatenation of these other two strings. So I realize this actually doesn't need to be this difficult. However, we want to learn a little bit here. And like I said, this is something that I've run into in the past already, where I would have liked to use a hash map, but I didn't know how to properly hash this class. How to set this up properly. Yeah. Excuse me. Well, you definitely need an equals here in order to have a contains that works properly, right? There has to be an equals. Two string pairs, comparing them to each other. But somehow this contains fails, and like what is the How about this? What's the hash code we get for each of these? 3152985. Okay. So we got that. So that's interesting because we inserted that with that hash code, we inserted a see, that's so strange to me. With that hash code, we inserted into the hash set, and how does this contains work? Right, that's my question. Because we have this hash code. It should basically try the hash code. So confused. Excuse me. Maybe we want to use contains key instead of contains. Maybe that's wrong. put, remove, add, clone. All of these. So this contains just keeps returning false. Which is kind of the issue, right? Even after we add it, it still returns false. False true. Oh no. Oh. Well, look at that. Imagine that. Huh. Well, that's really interesting. So I think what's happening here is I think what's happening is this is using the when you contain or when you add. I want to say it's using the object to perform the equals and the contains. Like I don't think. I'm very confused. I am extremely confused as to what's going on here. Oh, I think I know what's going on. I got it. Aha, I am supposed to override. I think I know what's going on. Let's try this. Still the wrong answer. Oh, there we go. True, true. Hey, there it is. I figured it out. Okay. That is a very subtle thing, but something you'll get wrong if you don't handle that correctly. There we go. All right, got it. Okay. All right, that took a while, but I think I understand. So the issue is this hash set. The way it's programmed, it uses a hash code function as well as a equals function, both of which are sort of built in, I guess. And they're built into every object. An object itself, objects have an equals and a hash code. Now you need to override both of these, and it has to be actually the object O all the way at the top level for your class that extends an object file class extends the object class. And the reason why you need to do it this way is because the hash set implementation will automatically call those two functions from the object itself, that at the top level, unless they're overridden, right? Unless you override those. Which, by the way, I don't think you actually need this tag. I don't think it really matters. I don't know what that does. But yeah, you need to actually correctly override those functions. Otherwise, it won't work properly. Yeah, I think this is just an annotation. I don't know what this annotation does ultimately. But let's go for it. See how we do. Aha, looks like we're okay. So that's how you can use a hash map to create a like how you can combine different objects if you wanted to, if you needed to, into a single object, and then use that as a hash key. Like I said, I actually had used a tree map instead of a hash map, But you could just as easily use a hash map for one of the approaches, one of the problems that I had looked at previously. And yeah, a simple XOR of the hash codes of each of the elements should be fine. Should be sufficient. It doesn't actually matter with hash sets, hash maps and hash sets. You just want like a reasonably good hash function that doesn't have too many collisions. Unless you have some application where you need like some super optimized, like really make sure that your hash keys don't collide. You like really want to. I guess if you really want to reduce your collisions for whatever reason, then your hashing functions, I guess, have some. I guess you do a little more research on that. So okay, that took a while, but very interesting. Yeah, I'm glad we did that. Glad we went over that. All right, let's do like, I don't know, a couple more, and then take a break. How are we doing? 30, 31. That's pretty good. It's pretty good. Or excuse me, no, not 31. Yeah, 31. Okay. Java generics. Generic methods are a very efficient way to handle multiple data types using a single method. This problem will test your knowledge on Java generic methods. Let's say you have an integer array and a string array. You have to write a single method print array that can print all the elements of both arrays. The method should be able to accept both integer arrays or string arrays. Okay, you're given a code in the editor. Complete the code so that it prints the following lines. 1, 2, 3, hello world. Do not use method overloading because your answer will not be accepted. Okay. Write your code here. So a class printer. How do we do this? So we have printer equals new printer, integer array, int array, string array, hello world, my printer, dot print array, dot int array, dot print array, string array, and then we say, method overloading. Oh, that's the, let's see. We have, this actually is just to count the methods that you have, so you really just want one method with generic method. Print array, int array, print array, string array, count equals 0, method, printer.class.get declared methods, string name equals method.getName, if name equals print array, increment the count. So we can't overload. And then if count's greater than 1, okay, so we want just one print array. Okay, so void print array, which would be, I guess it's void print array. Take some, really it's an object array, I guess. I mean, you could do this way too, and then use instance of, but we want to use generics though. So how do we use generics? Doesn't explain generics here at all, which is fine. So I'm glad we went through our hash maps before. So let's look at Java generics, how we can do this. Non-trivial software project. Bugs are simply a fact of life. Careful planning, programming, testing can help reduce their pervasiveness, but somehow, somewhere, they always find a way to creep into your code. This becomes especially apparent as new features are introduced in your code. Base grows in size and complexity. Fortunately, some bugs are easier to detect than others. Compile time bugs, for example, can be detected early on. You can use the compiler's error messages to figure out what the problem is and fix it right then and there. Runtime bugs, however, can be much more problematic. They don't always surface immediately, and when they do, it may be at a point in the program that is far removed from the actual cause of the problem. Generics add stability to your code by making more of your bugs detectable at compile time. After completing this lesson, you may want to follow up with the generics tutorial by Gilad Bracha. Why use generics? In a nutshell, generics enables types, classes, and interfaces to be parameters when defining classes, interfaces, methods. Much like the more familiar formal parameters used in method declarations, type parameters provide a way for you to reuse the same code with different inputs. The difference is that the inputs to formal parameters are values, while the inputs to type parameters are types. Code that uses generics has many benefits over non-generic code. Stronger type checks at compile time. A Java compiler applies strong type checking to generic code and issues errors if the code violates type safety. A Java compiler applies strong type checking to generic code and issues errors if the code violates type safety. Fixing compile time errors is easier than fixing runtime errors, which can be difficult to find. Okay. I think that makes sense. Elimination of casts. The following code snippet without generics requires casting. Array list, add hello, string s, get list, get. Yeah, that's actually what I was about to do, is to use casting. I can cast my object to a string or to an integer. A string array or integer array doesn't necessarily matter. When written using generics, the code does not require casting. This string, new array list strings, add hello, list get, no cast. Enabling programmers to implement generic algorithms. By using generics, programs can implement generic algorithms that work on collections of different types, can be customized, and are type safe and easier to read. Yep, it's good. It's a good thing. Generally speaking, it's good. Generic types. Generic type is, I actually am, there's also code duplication. I guess in Java, since everything subclass is an object, it's a little bit different. But in C++, where no such concept exists, you do have, you do have such a thing as duplicating code, where you'd want to use a generic so you don't have to duplicate the code over and over. With Java, you can you can always have non-duplicated code by just implementing your code over over just an object, an abstract object. So you kind of always have that ability in Java. It's a little bit different. You actually do reduce code duplication in C++. But anyway, moving on. So generic types. A generic type is a generic class or interface that is parameterized over types. The following box class will be modified to demonstrate the concept. So begin by examining a non-generic box class that operates on objects of any type. It needs only to provide the two methods set, which adds an object to the box, and get, which retrieves it. So we have object set, get, box. Okay. Except to return an object, you are free to pass in whatever you want, provided that it is not one of the primitive types. No way to verify compile time how the class is used. One part of the code may place an integer in the box, expect to get integers out of it, while another part may mistakenly pass in a string, resulting in a runtime error. Generic version of the box class. Generic class defined with the following format: class name, different template formats, or template. Classes, yeah, template classes. Type parameter section delimited by angle brackets follows the class name. Specifies the type parameters, also called type variables. To update the box class to use generics, you create a generic type declaration by changing the code public class box to public class box t. This introduces the type variable t. That can be used anywhere inside the class. Okay, it's almost exactly the same thing as the C++ templates. How do we? Yeah, I think it's called templates. Yeah, C++ templates, right? Now, does that work? I don't know. Does this make sense? For some reason I'm thinking this is not going to work the way that I'd like it to. Oh, okay. Wait, what? Why? Hold on, what? Okay, so this printer, I guess you'll end up calling. I guess you'll end up having two of these print array methods. See, that's really strange. One, I wasn't expecting this to work. Apparently it does. Let's see. But also, I wasn't expecting this to work, but also, like, how does that make sense? You know? Because this printer class, it has two methods, but how does that work? I don't understand that at all. I understand somewhat. Basically, in C++, templates are effectively like copied code. Like it basically just pre-compiles your code, pre-processes your code, and just copies it, the things that are needed. But if you create a printer class that's printer of integers and a printer of strings, those would be two different objects. I guess that's what I'm trying to say. Is this looks like a printer class that, even though, like, what type is this? Like, it's printer of, I don't know what this one is. Yeah, that's so confusing to me. That's extremely confusing to me. It seems that you can call this function with any object, and it'll use that object. But there is only one method. It seems that this could be any object. That's interesting. Kind of would want to tinker with that a bit. Like, is this an instance of printer integer or printer string? I don't think so. How come? How does that work? Maybe it's like an interface then. Type parameter and type argument. Okay. Interesting, there's a difference between those two things. So it doesn't create a new box object. It's an integer box. We'll hold the reference to a box of integer. That's how box integer is read. Invocation of a generic type is generally known as parameterized type. Instantiate this class, use the new keyword as usual, but place integer between the class name and the parentheses. So what's weird is that we didn't need to actually include anything for this new printer. Like, this worked regardless. The diamond. So the diamond notation. As long as the compiler can infer the type arguments from the context. Type interface. Or type inference. Hmm. Oh. How about that? Compilation error. Oh, it's before void. Oh, that's interesting. So this makes a lot more sense to me, doing it this way. But I guess what's happening is that this is sort of being applied over everything if you put it up top here, but here it's just for this function. And that's very interesting that you can actually, yeah, the declared methods are, it's only this one, but excuse me, I guess the actual methods that are created when this is all compiled, there probably is two separate methods, one for integers, one for strings. That's my thinking. Okay, that makes a little more sense. Maybe that's the way to understand this. It's not necessarily creating, you don't necessarily need to create the whole object the way you might think you would do that in C++. I guess in C++ it's also not necessarily the case either. I think probably the similar thing would probably work in C++ as well. Although I don't know, yeah, I think you can template just a single function, I guess. I don't know if it works the same. Like in C++, if you template the class, I think it creates an entire new class with this object, this object type set. Whereas if you template just a function, it'll be just that function. I don't think it necessarily like translates to applying that template to every method internally. So that way you could use only an object of like printer and then still be able to have like templated or generic methods. That's really interesting. I think this is a little bit different from C++, but it's very similar, but it's definitely a considerable difference. All right, what's the next one? I think we'll take a break. Yeah, I just want to like go lay down for a minute or two. It's the comparator. Oh yeah, we were just doing this before with comparators. Tinkering with comparators. So yeah, thank you all for watching. Like I said, I'm gonna take a break. It's enough for now. 2.5 hours, pretty good amount of time. We have another 32. We're sort of halfway through the challenges. We're making progress. I think the speed and pace will pick up once we get going too. So yeah, I think I'll take a break for maybe an hour or two or whatever. I don't know how long, and then probably come back. and resume. And yeah, I guess thank you all for watching. I will talk to you soon. Have a good rest of your day. I don't know what else to say. I think I'm gonna be back later. Yeah, I think I'll be back later. So yeah, all right, take care.